So here's the Navy Evo 3.0 6-horse gas equivalent electric outboard, and this is the 6-horse gas Sail Pro motor. Now when this one's tilted up, it sits about that height at that angle, and so to get this one to tilt up, we're going to release this lever here, and then we tilt it up until it clicks. And then you can see that its standard position here is lower than this one. So if we need it higher, we'll have a rope tackle that can lift it up to whatever angle we need once it's in the outboard well. We've got the battery hooked up with the Shore Power battery charger, and got the remote throttle and the display, and we'll give it a test here at low speed. So that's just 100 watts of output, about 600 RPM. In order to build this outboard well to fit both the gas 6-horse and the electric 6-horse, I've got to compare the two different motors and have a sketch from my last outboard well for gas motor on a Triton, which is similar in shape to the Cape Dory 27 here, but there are some differences. This is a higher deck, so the locker's deeper. And here I've set down the pattern for where the hull cutout will probably approximately go as I'm checking measurements, and then this plumb line with the tape marks is giving me reference for different clearance points. So I want to make sure that I don't run out of space for the motor to hit the back of the transom, or when it's tilted up, it still has clearance aft of the tillet. And then we're going to have to cut this hatch out and cut out here for access, and remove all the fittings and hardware, chain plate, knee, all these through hull fittings have to go, and then we can get in there and see what we need to do. I'm going to remove this backstay chain plate and its backing plate, which is a welded iron bracket here, which is glass to the hull. You can see the steel is already flaking away from corrosion, so it has to come out anyway. We've cut out that forward bulkhead for the lazarette and the after deck, and we're going to reuse it by glassing it in place in this further forward position. Got the chain plate and the knee out, and this came apart in some rusted chunks, still holding together, but just barely. I've cut out the hull and transom where the motor is going to drop into, and I've made the motor mount board and just temporarily secured it in place with these 2x4s to test the fit. We're dry fitting the gas motor now, and we decided we had to cut out for a hinge door here, and we'll have to not use the traveler. We'll have to go to 3-point end-to-boom sheeting with stand-up block here and here, as on the other boats I've done, because there's no clearance for tilting it up, or you want the door down also for pull starting and for the tiller handle. And when the motor is down in the motoring position, we can give it full side thrust when needed to get out of a tight marina slip. And there is still about 3/4 inch clearance between the motor and the transom. And when it's tilted up, we have a little over 1/4 inch clearance here between the motor and the new bulkhead position. So those are the limiting factors to keep the engine low enough so the prop stays in the water, but also to have clearance between the transom and the motor head tilted up and the bulkhead. And for that, you need about 28 inches minimum horizontally between the rudder head fitting and the transom. And also you have to keep about a 1-inch gap here so that this can be removed for maintenance, because the rudder shaft's coming up at an angle. So when this comes up, it goes aft. So there's clearance for that. Up here, we've got a 1/2 inch clearance with the original hatch height to clear the motor. If we didn't, we could add a little height here. The electric motor is smaller than the gas motor, and so it has plenty of clearance aft to the transom, as well as up forward here to the bulkhead. And this will flex out of the way, but we will have to cut this floor out. We're going to put a buoyancy chamber under here anyway, but it's going to be lower and angled back for drainage. Also has side thrust, no problem. I also had to cut out this area at the aft end of the footwell to get more clearance for the motor when it's tilted up. So we're going to use a wedge filler block in here, which is 1 inch wide at the top, tapering to 0 at the bottom, removable wedge, so that it will bring it back into 0-degree alignment when motoring, even though it's in the 5-degree tilt angle. And that way we can grind that wedge a little bit one way or the other to get a perfect fit. So we've put the motor back in one more time so we can check the fit of a pattern I made out of cardboard for the gas tank shelf supports. So when that's in place, there we have the motor tilted up to get gas tanks in and out. We got to make sure there's good clearance under the deck. And transfer that to 1/2 inch plywood. I've put a couple coats of epoxy on the backs and bottoms of these gas tank shelves, and there's also a 1-inch wood cleat installed to support the shelf. One last dry fit of the panels to check the fit and get them supported, and then we'll grind some more of the paint off the fiberglass and fiberglass them in. Here you can see that the shelf top is clamped up out of the way so that I'll be able to first fiberglass the inside and then lower it down and glass the top. Otherwise you can't fit the board in through this opening later. We're going to put in these 6-inch Bexon deck access plates here where I've circled it. underneath the gas tank shelf for access and storage. We've got these panels glassed in now using 2, 4, and 6-inch fiberglass tape, about 10 ounce. And now we have to add the top to this center buoyancy chamber. I've fiberglassed in the aft board in that center buoyancy chamber, so that's all sealed off. And before we put the forward bulkhead back in here, I'm going to fix the rotted core in the cockpit footwell by cutting that out. Otherwise, we'd have more trouble fitting that bulkhead and cutting it out later. Underneath the wood blocks here, this crack was exposed and the screw holes allowed water to go into the balsa core. So that was some sloppy work at the factory, but pretty common. Happens on a lot of these older boats. We cut this out and it came out easily, except it was still glued down in this corner where I had to rip the fiberglass a bit. And the core is all rotted. There you can see the moisture coming out of it. So we're careful to leave the bottom layer of fiberglass uncut so we have something to work to fill it with the new core. After taking the rotted core out, the inside layer of fiberglass was so thin and uneven, I needed to flatten it and strengthen it. So I epoxied a 3/8 inch plywood underneath, screwed together temporarily with this 1/2 inch plywood on top to get it all flat and to support it until the epoxy hardened. And I put this thin plastic sheet underneath this top piece so that it's easy to remove. Here's the 3/8 inch plywood underneath with some temporary bracing holding it in place. Putting down thickened epoxy with this serrated trowel on the fiberglass. And I've already wetted out the fiberglass and the bottom of that Davini cell, so it gets a good bond, and filled in all the edges. Now we're doing the same thing for the top skin of fiberglass. Wet it out with unthickened resin and then put thickened epoxy using this 406 West System silica. Then I'm going to put some screws in here to hold it all together and tighten it up and get rid of any voids. After grinding the fiberglass joints, I put down some fiberglass tape, and now that the footwell is solid, we can carry on with the outboard well. To strengthen the transom, I've added this 1/2 inch plywood with fiberglass. The backing plate for the backstay chain plate was all rusted out, so I fabricated a new one by TIG welding this out of stainless steel. Fitting these sliding cover boards, in this case I'm using 1/4 inch Coosa that I will cover with fiberglass, Could also use 1/2-inch plywood and seal it well. So you have to set the two separate boards on each side in place and then glue them together with thickened epoxy, and then they can be pulled out and glassed without losing their shape. I've filled in the gaps in the deck with plywood and fiberglass and cut the hatch in half and spread it apart and measured that we need about 10 inches filler in the center. So I'm going to put a 1/2 inch of plywood under here since there's already a gap anyway with that long lip down at the deck, and that will stiffen it up so it can be walked on. Right now it's very thin and not strong enough for walking on anyway. This is the front door that'll be hinged down so that you can have access to pull start it straight out. Cover boards will fit like that. And there is the chain plate, backing plate for the backstay, fiberglassed in. After the 1/2 inch plywood is attached, I ground back a bevel in the fiberglass to add more fiberglass to it. And then I have to put some glass on these sides also. There's the gas tank shelves for when using the Tohatsu motor. Otherwise, they could be used for dinghy outboard gas storage if using the electric motor. These are the teak cockpit combings. I had to shorten the ends here about 6.5 inches and reshape them to fit the new bulkhead position of the outboard well. And the teak was badly weathered, so we have to sand it with 80 grit to get it flat again, and then 120 grit to get rid of the 80 grit scratches, and then it'll be ready for varnish to help protect it from weathering in the future. We're coating these exterior teak pieces with Seatol Natural Teak. We're going to fill in this prop aperture in the hull and rudder. So I've cut a couple of pieces of heavy paper to use as a pattern, and then I'm going to trace these out onto some plywood and start filling it. Using the Sawzall and the oscillating tool to cut out these engine beds now, because I want to put the house battery there. The engine beds are out now, and we've got very rough hull surface to smooth out, and then build in some supports for the battery. We're hoisting the E80 lithium battery, and it weighs 106 pounds, so we're using a tackle. Okay, to get the battery back into its platform underneath the footwell, we change the tackle position and use a 2x4 lever arm, and was able to walk it right back in here. We've got the 48 volt battery installed, and we're testing the motor now. So here is the positive and negative from the battery to the switch, and a communication cable in the center goes to the display and the throttle, and then the battery charger cable plugs in here for a communication cable, and on this side it is a remote on-off switch, which is up here. I'm going to install it there somewhere so that you don't have to access this battery because it will turn itself off after 24 hours of not using it. So you have to have a remote switch if you don't want to have to climb down into the battery compartment. Behind here is the electrical connections for it. We've got a battery charger, 48 volt from 120 volt AC for shore power to charge that battery. And then we've got the positive and negative bus bars and a shunt here for the amp hour meter. And this will be a converter to charge the 12 volt house battery when needed from the 48 volt battery. Got the throttle mounted on the side of the cockpit, and the cables from the motor come through in this black bundle here, and we've got a communication cable that I cut and put this disconnect fitting in so that I wouldn't have to pull the cable all the way out from the battery when you swap the motor out. And then it has a disconnect there, and the disconnect for the battery positive, and a place to disconnect the bus bar for the negative. And then that goes under the footwell down to the battery and the instruments. And here's two more communication cables that go to the back of the throttle. And we'll test the motor. Put the throttle into forward slow. And here's the display, dry fit for now. And it just shows the watts being used, the speed, and the RPM of the prop. And up here it shows 53% state of charge of the battery. Now if you toggle here, you get miles per hour, kilometers an hour, knots. If you hit the OK, it goes to voltage up here, 52 volts, or back to state of charge at 53%.